Hello everyone. So in this video, I'm going to talk about how we can use the Pythagorean in 3D figures. So with using some common questions, okay? But before we get started, let me remind you the Pythagorean, okay? Since we are going to use that in our questions. So Pythagorean is just a relation between the sides of the right triangle, okay? So if you have a right triangle like this, even though I said right triangle, but we can use the Pythagorean in other triangles as well. But for now, let's get into right triangle. So A and B and C. Let's say this is a right triangle with 90 right here. So the Pythagorean says the square of the legs, which is the side that is next to 90, is add up to the square of the hypotenuse. Okay, this is the Pythagorean. So the question is asking like every vertical cross section of this triangular prism is isosceles triangle. So which is a triangle that has two sides are equal. And based on this, what would be the height of this prism? So we do know this guy is 5, and we are told the cross section, which is this guy, as a triangle is isosceles, which will take this piece is also 5. Okay. And when you drop the altitude, maybe I should draw this separately so you can kind of see it. So if I want to draw this cross section as a 2D figure, right? So it will be like this. And I will drop the altitude. So what we know is this is 5 and this is 5. And then since this is altitude, this is 90 degrees. And this is the h. And since this is isosceles and then the base is given as A, so when you have the isosceles triangle, the altitude will split the base into two equal pieces. So which is why this is going to be 4 and this is going to be 4. So at this point, you want to use the Pythagorean in this triangle or in this left triangle to find the h, or you can remember the some Pythagorean tuples, which is one of them is like 3, 4, 5, right? So if you remember 3, 4, 5 Pythagorean tuples, so this is 5, this is 4, that means this is 3. But if you don't, let's use the Pythagorean itself. So that will give me h squared plus 4 squared equals 5 squared. And if you square 4 and 5, so you will get h squared plus 16 equals 25. So the h squared, if you subtract 16 from both sides, it will give me 9. So the h will be just 3. Okay, so that is the answer for this question. Okay, this is the second question. So in this problem, we have a prism again, and what we want is the diagonal, which is the segment that you can draw from two opposite like corners. And well, this even has a special name, which is we call space diagonal. So this goes through the inside of the prism. So this is what we want. But how do we deal with that? So like I said, we are going to use the Pythagorean, but there is no right triangle. So which is why when you are dealing with 3Ds, so you have to see some right triangles and make them a right triangle if you don't have one. But what I can do, I can connect this vertex to this vertex. And if I look at this triangle now, the since the since the each side, like the vertical sides, are perpendicular to the base, the angle right here is also 90 degrees. So angle in between this side and this diagonal is gonna be perpendicular, so which is 90 degrees. So now we have a right triangle right here. So we do know this is 6, which means this is also 6, this is also 6. So let's write that. But I do need this D, so which is why I do need this diagonal as well, which I don't know. So if I call this is A and B, and we know this, the base is a rectangle because we are told this is rectangular prism. So the angle in between those 2 and 3 on the base, like as a floor, is 90 as well. So if you use the Pythagorean in this base first, so we can get AB squared. So let's go ahead and do that. So Pythagorean was telling us A squared, B squared, add up to C squared, right? So I can take 2 and 3 as AB because this is 90, so those two are the next size. next to 90 degrees. So 2 squared plus 3 squared will be AB squared. And that's 4, that's 9, which is 13, equals AB squared. So AB is not 13, but AB squared is. You may find the AB if you want to, but we don't really need that. We like to find the, so to do so, I'm going to leave it AB squared as 13 because I don't need AB itself. So now if I want to take this triangle, okay, and use the Pythagorean in that right triangle. So let me use different color. So then you will get AB squared plus 6 squared equals D squared. So make sure you really understand this before you move on. So what I did was, this is AB, let's say this is C. ABC is a triangle, and then the angle right here is 90. So AB is one leg, and BC is another leg, so which is 6. And then the sum of those two legs, like square, has to be square of the hypotenuse, which is the AC in that case. And I do know AB squared is 13, so I can replace with that, and that is 36 is equal to D squared. So if you add these guys, you get 49 is equal to D squared, square root both sides, so D will be 7. And that is our final answer. So there's a shortcut for this problem, but I will leave for you to explore that on your own, okay? So this is it for this question. Okay, this is the next problem that we have. It's kind of similar to the first problem. Only thing is now the side is not integer, it's just square, like radical number. So what we are told, the same thing. So each cross section is isosceles triangle. So if you remember, we took this triangle and then draw it separately, but I don't think we do need this anymore. Since this side is like given 3 root 3, so this is also 3 root 3 root 2, and this is also 3 root 2. So this is an isosceles triangle when you drop the altitude. So that will be divided into equal pieces, okay, which is 3 by 3. So now we may use the Pythagorean in this right triangle. So that will give us h squared plus 3 squared equals 3 root 2 to the second power. And that will be h squared plus 9 equals, if you square this one, which is usually not too nice for some people. So 3 root 2 square, you can just write it twice if you don't know how to deal with that in the first place. That's basically 3 times 3, which is 9. And then root 2 times root 2 is 2, which will give me 18. And if you subtract 9 from both sides, so h squared will be 9. So the square root both sides, so you will get 3 for h. And we are done. So some of you actually don't need to do all of these process. If you do know a special right triangle that is 45, 45, but this is the case in our problem because the hypotenuse is 3 root 2 and the leg is 3. So if you do know 45, 45, this is the case, but I'm going to leave it for later for these problem, okay? But we can just use a Pythagorean to get what we want, and that is the answer. Okay, this is the last question. So it's similar to the second question that we just did. So if you want to pause the video and try this on your own before I do, that would be great for you to learn better. So we do need to find the diagonal, which is like given this piece. So we have other 3 sides. If you remember that problem, we actually made a right triangle and then use a Pythagorean. So I can connect this vertex to this vertex, so I can see the angle in between this red diagonal and this side is going to be 90 degrees, so I can use the Pythagorean. So since this height is 2, this height is all 2, okay? And now I do know the angle in between those 4 and 7 on the floor is also 90 degrees, so I can use the Pythagorean. So I'm going to call this is A and B and C. So in the triangle, let's say this is H, ABH. If I use the Pythagorean, so you will get 4 squared plus 7 squared equals AB squared. Okay, so that is 16 and 49 equals AB squared. So that is 65, right? AB squared. So if you remember, we may try finding the AB itself, but we don't need it because at the end we're going to square that AB anyway to get D. So which is why I'm going to leave that as it is. So now in the triangle like ABC, this is also a right triangle. So I can use a Pythagorean. So that is A squared plus B squared equals C squared. So A and B is like 2 and AB. So I will say 2 squared plus AB squared. So AB is just like AB squared is 65. So I'm gonna call this is 65 equals D squared. Again, if you didn't get this part, so make sure you write like AB squared plus BC squared. Okay, this is AB. Maybe I mean this is AB, B is AB, and A is like BC, and C is D. So I just plug those, and that's 9. I mean that's 4 plus 65, which is 69, equals D squared. And if you take the square root, so you will get square root of 69. So you can plug this in your calculator to find approximate value, but I'm gonna leave it as square root of 69 because that is much accurate. Okay, so I hope this question is useful and helpful. So I'll see you in the next video.